Today I'm going to talk about enabling faster intelligence gathering and usage, I should say, with GenAI and OASIS Open standards. So the format of this is going to be essentially a bit of a case study, a small proof of concept, and I'll walk through how we built it out in a very short period of time through the rest of these slides. So jumping straight in, just a bit of background on who I am. So I'm an AI engineer at Rapid7. I'm part of the AI engineering team, and our focus is obviously on applying machine learning across our platform in whatever way we can to sort of help our security analysts and our customers. So that can range from building detections or alert triage with the more traditional machine learning approaches and our classifiers, or to the more recent and exciting advances in large language models. So everyone here has probably heard of ChatGPT as well. And using that in more advanced applications such as retrieval augmented generation. So prior to Rapid7, I actually worked as an incident response analyst at Proofpoint. And before that, I gained my PhD at Queen's University Belfast. And the focus on that was applying deep reinforcement learning to network security, and specifically focusing on automated intrusion response systems. So this is actually my first sort of bit of a dip my toe into the world of threat intelligence, but looking forward to see what we can build and how we can integrate AI into that process. So first of all, to talk about what we're actually going to talk about today, this is the agenda. So we're going to start out with a bit of recon or a background. So we're going to set a target. So because this is a case study walkthrough, we need to talk about what we're actually trying to achieve by the end of this presentation. There are a few spoilers here, but I'll talk a bit about AWS Bedrock, talk a bit about Stix, which I'm sure a lot of people here are already very familiar with, and then another standard, which is probably not as popular, but CACAO, or the Collaborative Automated Course of Action Operations. I'll probably stick to using CACAO for that. Then we'll go into how it's actually built. So we'll talk about actually building a very simple Python script as our threat intelligence collector. So we need to pull in this information. Then I'll go into how we integrate GenAI into to use this information that we've collected. And then finally, what are we going to deliver at the end of this? So we're going to have, hopefully, working CACAO detection playbooks. And then finally, I'll finish with just how can this be used potentially by industry and any key takeaways. So to start off with what we're trying to achieve, and I figured an interesting and new way to start this out is always with a deep and meaningful quote from somebody who's obviously a key figure and very influential in the threat intelligence and security landscape, and that is Cristiano Ronaldo. So Ronaldo here says, "Dreams are not what you see in your sleep. Dreams are things which do not let you sleep." And this is interesting to us because if you ask a security analyst, what they dream about whenever they sleep, your typical answer, and something I would have said whenever I was working as an incident response analyst, is, what is sleep? So with Rapid7, obviously, our goal is to drive down the time to action across our platform for our analysts and for our customers to respond to certain threats or even just improve their security posture. And so obviously one area that everyone's heard of lately over the news and social media is GenAI and large language models. So that allows us to identify our target that we're going to try and achieve by the end of this talk, which is, can we go from a newly published piece of intelligence to a CACAO detection playbook in under a minute? So how are we actually going to do that? So first of all, we're going to obviously need intelligence to build this system, so we need to collect our intel. So we're going to start out with a very basic Python script, which just draws different sources of intel, pulls it into our application. And I should say we're using open source information here. We'll go from that collected intel to use an LLM to generate Stix indicator objects. And from there, we again utilize an LLM to generate a CACAO detection playbook. And I'll talk a bit more about the detection playbook later on in the slides. And then finally, what we can do is we can either present this detection playbook to our analysts for a quick review, or in some cases where it's not too impactful to automatically deploy this to your systems, such as your network intrusion detection system, we can go ahead and do that. And that's part of the beauty of CACAO playbooks. So to jump back a bit then into some of the background, what exactly is Amazon Bedrock? So as it says here, Amazon Bedrock is a managed generative AI service which gives us access to a range of the latest and greatest in terms of large language models. So for example, Bedrock provides access to Anthropic's Claude, It also provides access to Meta's or Facebook AI's Llama models, and then AWS actually have some of their own generative AI LLMs available that you can use, such as Titan, I think one of them is called. So we actually use Bedrock at the minute for several of our in progress or proof of concept works, and it actually is already being used in some of our production use cases. And I think the reason why we are using Bedrock is for these three reasons pointed out here. So first of all, it's serverless. We can interact with Bedrock the same way that we would interact with any other AWS service. We don't need to spin up any infrastructure to run these or interact with these models. It's cost efficient in that we don't have any specific fee to use this system. We're only charged for whatever tokens we send and get back from the large language models. And then finally, the one which a lot of people might find interesting is obviously privacy. So the nice thing here is that anything that we send in terms of our prompt or any additional information is not logged by AWS in any way. It's not used to train their models, and it's not provided back to the original model provider, so your Anthropic or your Meta, to train their models either. And the same thing counts for whatever the model generates for us. It's not logged. So that's a huge advantage for us. But one of the other nice things about using this tool or this service for application development is actually how easy you can interact with it from your application. So within Python, you can of course interact with it the same way you would interact with EC2 or Amazon S3, in that you can usually or essentially just use the API. And there's several really useful packages in Python that actually already exist. And a favorite of mine is LangChain's Chat Bedrock. And what I can do with that is, in building my application, I can go from creating an instance of DLM, whichever one I choose. So for example, here we're going to talk about Anthropic's Claude 3.5, and actually interacting with it, sending it a prompt and getting a response back in as little as 2 to 3 lines of code. Another thing I wanted to point out that's not on the slides here is Bedrock's really useful whenever you want to compare the performance of different large language models. So in that setup of your Python application where you're interacting with Bedrock, to change to a different model, you literally only need to change a single parameter or the name of the model in your code. So if you want to compare how each large language model performs without changing the rest of your application, you just change that one parameter and then you can collect the results and do your comparison. So it's really useful from that perspective as well. So just a bit more in the background. So Stix, I'll not linger on this too much because I'm sure people here know about it quite a bit. But what is it? So it's a standardized format for representing threat intel. And I think the goal obviously is to allow collaboration and sharing, firstly across organizational boundaries, but also between machines. And the great thing about it is it's quite widely used and adopted at the minute, which is great. If we look at the example on the right-hand side here, this is an indicator object, and this is what we'll be specifically generating with our large language models through the rest of this case study. So we have information here such as the name of the indicator object, so it's the malicious IP, the short description, so this IP has been associated with a malware distribution, and then we actually have the indicator itself, so the IP address. And although a lot of sources of Intel might already provide this structure, there are some interesting sources which actually don't. And if we can use an LLM to generate this on the fly, then that's great, because getting it into this standardized structure is really useful, especially when you're building out applications to work with this. So next up is probably the lesser known of the two OASIS Open standards that we're going to talk about, and that is, again, the Collaborative Automated Course of Action Operations, or CACAO. And so what is this? Again, like Stix, it's a standard for a standard way of representing information, but instead of specific threat indicators, this is for sharing and representing automated cybersecurity actions. And so these actions can either be manual steps and be fully automated, or fully automated steps or manual steps that you put in front of an analyst. But for this use case, we're going to lean more towards the automated side. So they're machine readable and atomic, and it takes the form of a playbook. And so again, the goal here is to improve coordination, because if we take a look at this diagram on the right here, which I like to talk about, we have obviously the cyber kill chain here, and we can look at where threat intel actually plays a part across the kill chain. So for your intrusion prevention side of things, we can take things like our vulnerability information, our vendor advisories, and start to harden our systems to prevent certain attacks from taking place. And then at the detection side, we obviously have your IOCs, your signatures that you can use and plug in. And this is something that I linked into in my PhD, this intrusion response side of things, and how do we actually respond to certain threats which have made it into our environment. Information isn't quite widely shared on how to do that, and of course there's reasons why that is, because different organizations might have different infrastructure, different setups, use different tools, but the core concept of sharing information that can be used to help other analysts out can be encapsulated by these CACAO playbooks. And anyone who's worked in incident response or in that area will know what playbooks are, and are usually the steps that an analyst can take to follow when responding to one of these threats. So if we can start sharing that sort of playbook information and help analysts out, that's where the real power of CACAO playbooks will come in my opinion. But for the purpose of this demonstration, what we're going to do is we're going to build out a CACAO detection playbook, and I'll talk a bit more about that later. But essentially, we are going to go from our intel, collect our indicators from the intel in the Stix indicator objects, and then from that we're going to build a CACAO detection playbook, and that's something which aims to help fit into our event structure if we have, for example, a NIDS, and automatically, let's say, update with new rules to detect certain threats. So jumping into how we're actually building this out, and first of all, we obviously need to collect our intel from somewhere, and we need a method of doing that. So whenever we're thinking about what we could collect, there are obviously several free sources of intel that we're considering and can use for this. So on the right-hand side here, we could use Alien Vault. We could work with the API there to collect pulses and indicators from that. We could work with NVD, so we could use our API, check for any latest disclosures, and then from there we could go into them, check for any references to, let's say, vendor advisories, and again, check for any indicators there. CISA, they're actually really great in that a lot of the time they provide Stix indicator objects straight away, so that would be a win-win in that we wouldn't need to have this first step. But for the purpose of demonstrating the power of what GenAI can do here when we integrate it with this process, we're going to go with RSS feeds. And to make it even more odd, we're going to go with Krebs on security articles. So the process here is we have our Python script. It will connect to the Krebs on security RSS feed. It will parse it. We can do some update checking here, so we can hash whatever we pull back from the RSS feed, which would be the full article, and compare that to what we've collected before, so the hash of the previous one. And if there's any difference there, we can assume that it's been updated, collect the new intelligence, and again, we'll pass that on to the next stage of our application, which is using GenAI. So how do we actually integrate GenAI here? And so what we're going to do is we're going to take what we collected from the previous step, so the Krebs on security article, which is all natural language descriptions, I should say part of the reason why we use Krebs on security articles is because it's actually quite good on at including indicators. So we append this to the bottom of a prompt that we're going to send to our large language model. And this is a very simple prompt. There's no chain of thought reasoning included here. There's no end-shot prompting, which means that we're not providing tons and tons of examples on how to do this process. So to go from an RSS feed to a Stix indicator object, we just talk through it. So to step through this here, I like to hype the LLM up a little bit. I say you're a threat intelligence expert, and you're an expert at parsing and interpreting both structured and unstructured natural language threat intelligence. So specifically, your purpose is to identify relevant indicators of compromise from the data that we provide you, and then populate those into a Stix indicator object. There's a couple of things to point out here in terms of the prompt. So it is quite basic, but one of the things here to take note of is we want to be very explicit, because this is part of an application and we have to control the flow of information through it. We want to be very specific on how it outputs information. So typically, if you just ask an LLM to do something, it will give you what you want, but it might provide some additional natural language explanation around it, and we don't want that. Of course, we just want the Stix object. So we explicitly say it here, return a Stix indicator object only. And the other thing, just on the point of calling it a threat intelligence expert, giving the LLM a persona to follow as part of the prompt, it doesn't actually make it any better at reasoning in terms of, what it understands about threat intelligence. But where it does help is making sure that how it responds, so the output is in a more realistic and more usable format, and the terminology that it will use will hopefully be more relevant. So again, here in the prompt, you probably notice that we don't give any example of how to actually do this process. We're actually relying on Claude's pre-training knowledge. So Claude is trained on a wide variety of information available on the internet. It's just scraped through their training process. And I'm pretty sure Claude is trained up until April or May of this year. So it already has quite a good working knowledge of Stix and Stix indicator objects. So we don't need to provide any additional prompt engineering to explain the format of Stix indicator objects. We just pass it straight in. So first of all, what does this do? So on the left-hand side here, and sorry if this is hard to read, on the left-hand side we actually have our RSS feed pulled from Krebs on security, and it contains the full article or recent article in natural language. And then on the left we can see the first output of the LLM or Claude, and we can see that it's pulled a couple of indicators from that and populated it into the Stix indicator objects. So we have a scam streaming IP address, and the description and IP address hosting multiple scam streaming domains, and then our indicator itself. So this is just a snippet of the output. There's a lot more indicators that were pulled from this article. Another one here you can see is a domain, specifically watchlive24.com. So now we have gone from our natural language intelligence to structured Stix indicator, and we can go on to the next step, which is generating a CACAO detection playbook. So similar to the previous step, we're going to take the output, so the newly generated Stix indicator objects, and append those to the bottom of this prompt. So if we go through this prompt again, we hype it up again, we say you're a threat intelligence expert, but this time we're saying you're an expert at generating collaborative automated courses of action detection playbooks. So specifically your purpose is to read and interpret these indicator objects, and where possible, so this is a nice part about using an LLM as well, we want you to create a CACAO rule to encapsulate those indicators that you've identified. And from there, once you've generated these rules, we want you to go ahead and generate the new courses of action detection playbook. So again, Claude here is already familiar with CACAO, so it can go ahead and build those. We don't need to provide any additional information, and it can just work straight out of the box. Now again, this is a very quick, and we spun this up a very, very short period of time, and it's not as developed as you can potentially build this out to be. So you can be a lot more specific in your prompts. You can be a lot more specific in your Stix objects and how you want them outputted. But this is just very simple prompts that we've put together just to see how it actually ran through on the first run. So again here, on the left-hand side, we have our Stix indicator objects that we got from the previous call to our LLM. And on the right-hand side here, we can see our newly generated CACAO detection playbook. And again, it's probably quite hard to see, but within this, you can see that we have taken one of the indicators and we have generated our CACAO rule. And on the point I just made before this slide around how you can customize this a bit better to your environment, you can probably see here that the SID is just the default first one, it's the first CACAO rule ever to be deployed in your environment. So whenever we think about building our prompt for this, we can pass in more detailed information about our environment. So we can actually pass the most recent SID in your CACAO deployment as a parameter to the prompt and make sure that the LLM knows to increment this and prevents any issues from that side of things. And then finally, just go over the system overview here to sort of recap, but also talk a bit more about how this can actually be used then. So we have our simple Python script, and it contains these three first steps. So we have our Intel collector, which pulls RSS feeds from Crayon Security RSS feed. We pass that to our Stix generator, which interacts with AWS Bedrock and Claude 3.5 specifically. And it creates for us our Stix indicator objects. We collect those and pass it to the CACAO generator, which again interacts with AWS Bedrock and Claude, and returns our actual CACAO detection playbook with our suricata rule embedded inside. So from here, there's a couple of options available to us, and one of the nice things about CACAO is that it lets you define how this actually gets deployed. So you can, the terminology they use is an agent and a target. So in our case, the agent is the software or the application that is actually going to execute this playbook on the target. And the target is, of course, the recipient of these actions. So in the case here, we're talking about suricata. The target could be your NIDS host and your suricata deployment. The other thing we could do here is, rather than going straight from our agent over to the target or your suricata or your NIDS deployment, we can actually just queue this up for a quick review by whatever security analyst you want. So we have our detection from a new piece of intel ready there, sitting, waiting, and isn't relying on the time taken for an analyst to build this out manually themselves. But we can still plug in and check. But for these CACAO detection playbooks specifically, whenever we're just deploying this to something which isn't going to take any actions on an environment, which can be, quite detrimental, and we're just simply deploying a new NIDS rule or suricata rule, this can just be automated and mean that we can go from no coverage at all to having our detection in place and running in our system, in a very, very short period of time. And the reason I wanted to specify this is because CACAO actually, and the power of it, means it can extend to different types of playbooks, such as a mitigation playbook. And a mitigation playbook can contain the steps or sequence of actions to take to mitigate a threat. And obviously, if you're actively trying to mitigate a certain vulnerability in a piece of software or something along those lines, you don't want this to automatically take those actions unless you're very confident. But for detection playbooks like this, we can go straight from the agent to the target. So what are the key takeaways from this today? So first of all, did we hit our target of new intel to a CACAO detection playbook in under a minute? And unfortunately, the answer was no. But the good news is we did do it in 66 seconds. So we're 7 seconds slower, but that is still really, really fast. And I think, regardless of what other implementations you have in place at the minute, integrating GenAI here doesn't actually necessarily have to be something which is directly making changes to your environment, but it can really speed up the process of building out these new detections. And if we can go from a Crayon Security article with certain indicators in it to a working suricata detection in our NIDS deployment, in 66 seconds, that's potentially something which could be useful. Again, this can be built very quickly, so this is a very simple proof of concept that was built out in a couple of days. It can be made more complex, and you can put a lot more guardrails and structure around to make sure it interacts with your environment correctly, or works with your environment or whatever tools you have correctly. We've shown that zero-shot prompting works quite well. Again, by zero-shot prompting, I mean we just provided very simple prompts, or we didn't add any additional examples of, say, going from intelligence to a CACAO detection playbook to the LLM. It just did this out of the box and didn't require much, heavy lifting from our side. And it worked quite well for translating unstructured intel to Stix 2.1 indicator objects, for generating suricata rules, which is a nice plus, and then also generating the CACAO detection playbook. So just to linger on this last point, so this can also be extended to other intel sources. So of course, we've shown an RSS feed with Crayon Security, which, at the end of the day isn't really ideal. Organizations will have their own sources of intel, and it could be proprietary or subscriptions you may have, and it can be extended to that quite easily. You just need to develop your integration quite a bit. And then also, again, the playbook types such can be extended from CACAO to not just be about detections, but about mitigations or even just the steps we should take to investigate a certain threat in our environment. And that's me. Thank you very much. Feel free to reach out to me on any of these socials, and I'll open up now to any questions anyone might have.